So we discussed arrays yesterday, and what we what we discussed was how to create an array and how to uh, access an array. So you can create an array using say the array type and the variable and the array size. Okay, so we and then we can initialize arrays in different ways. So here uh, so here sorry so in this case array is only created, it's not initialized, and here we initialize the array, and here we initialize with zeros, and here we initialize part of the array, and here so I couldn't explain this one. So if you say a integer a and empty square brackets equals 1, 2, 3. In this case, it will create an array of 3 elements because we supply 3 elements, and here we don't give the size, no size. Okay. For that, what will happen is it will create an array variable and assign these 3 values. To assign these 3 values, it will create array of size 3. Okay, and here so we have something like this integer a and an empty brackets. Here we don't create an array. See, there's no array here, no memory allocated. Therefore, so you cannot access array elements. So if you try to access array elements, it will be you will get some errors, and then we discuss how to access arrays. So so here so we create an array of size 5, and you can access any array element like this. Okay, and then we discuss so we didn't discuss this one. If you when you discuss integer a 5, so you create an array of size 5 here. Okay, and you can access a0 equals 12. So what happened is 12 will be assigned to this place. The same thing can be done using pointers. So so if you say a, so what is the meaning of this? This is, so we have a, actually this is a integer pointer. A is an integer pointer, a0 is a normal variable. So this is an integer, and if you take a, it's an integer pointer. So what happened here is in this line, okay, we can use this as asterisk mark and the pointer name. So this is similar to a0. So this is what we do here is we go to the a pointer a, that means the address a, and get the value. Here also we go to address a and get the first value. So these two are same. So to get the say ith value, say So what we do here is we use pointer arithmetic. So this is the starting address and this is the shift. How many element you want to go. So since this is an integer type, so this I will be I integers. That means I into size of integer. Okay. So this is similar to, so I will delete this. This is similar to AI. So this is very important. So we call this point arithmetic. So if you add I numbers to any address, it will shift by the size of the type. So if it is integer pointer, it will shift by I integers. If it is a floating point pointer, it will shift by I floating point values. So here it's the same. So this I means ith position. So we go to starting of the array, the starting address, and move I places. Say we don't know what is I. It can be somewhere, anywhere here. Okay, and so here this is same as the other thing. So you can get the address of any location like this. So this is a normal variable integer, and if you take %, you can get the address. Okay, so so I could not show you this last time, and here we discuss in C you can go out of bound. The C double plus does not check the array bound, so you can access. So if you have an array of 10, you can access say any position if the memory is not restricted, or in a restricted area you can assign it or you can access it. Okay, and we discussed then the heap memory and stack memory. Stack memory we discuss is created for any scope. So we for here in the stack memory, first for main it will create a stack, and then when we call this function, okay, stack, so in main it will create x variable and pointer a. Okay, and here what will happen is it will create a memory in the heap. So say this is heap out, so it will create memory here and assign this address to here. Okay, and then we call the function, and in the function also we will have a new variable for x, and for b also you will have a pointer variable. So this is a pointer variable, and you can store addresses in that, and then here we create this memory will be created in the heap memory. Okay, and so this one will be assigned to here, and then when we return from the function to here, this stack will be deleted, and then when we return from here, everything will be deleted. Actually heap also will be deleted, but stack will be deleted first. Okay, so we discussed this one in the previous lecture, so I just discussed okay. So then today we will discuss how to change the size of array. So for example, that's my cursor. Okay, so we create an integer array, say a. So what happened here is it will create an array of size 5. Okay, and create it in the memory. So what if so we can do some stuff now, and say we can assign values. Okay, and later time we want to change the size. That means, say for example, we want to add some more values to say we want to make it 10. What is the problem here? The problem is so we have say 5 integers. That means 5 into integer is 4 bytes, 4 bytes of memory, and we need new memory. So again 5 into 4 bytes. But since we create variables and we can assign variables, delete variables in the memory. So this and the other condition for array is the memory. What is the other condition? The main condition, memory is contiguous. That means one after the other. The memory is in the same place, one after the other. So this part, the new part, should be say starting from here, and you have to allocate 20 bits. So this one is not you cannot guarantee this. Okay, the reason is because you may have used this memory for something else. So after you create the array, so after creating the array, you cannot change it. Cannot change it. Okay, so we call it static data structure, because the reason is after we created the array, we cannot change the size of the array. So, but we may have to do it sometimes. So when we are inserting elements, you may have to the array size may be not enough, so you may have to change it. So to do it, so this is how we do it. So first, so we have the array, initial array. So this is the initial array, and then what we do is we create a new array. So this is, we use new variable, new keyword to create the array of size 10, and we store that in a temporary variable, temporary pointer variable. So this address is new in the new array. So after that, we want to use a loop. So there are functions in the C and C++. You can copy a block of memory. We will use it later, but the concept is you have to copy all the old array values to the new array. So the old array size is 5. So from 0 to 5, you have to copy from A to temp. Temp is our new array. You can see that name is temp, and then we want to do this. So what we will do is, so first we have our new old array, and say we have some data. Okay, and if we want to change the size of this array, what we do is we have to create a new variable pointer and create a new array of required size, say 10 here, and then you have to use a for loop, int, so I equals 0, I less than this size, this size, because we want to copy the old array, I plus plus we have to increase I by 1, and then we copy the old array, which is A, into new array. And after that, what we will do? So now what happened is, so we have say here the old array 1, 2, 3, 4, 5, and here we have the new array, whatever. So first 5 elements are copied from the that array. So this is now temp. We use temp pointer, and this is A. Okay, and now after this copying, our program should, so our array name is A, so we have to change the names now. So A should point to this one. So what we will do? So we say A equals 10. Okay, so now the variable A will be pointing to this memory location. So now if you take A1 or A6, A5, sorry, A5, so this fifth position, it will access this location. Okay, say A5 equals 10. So this one, we have to delete. So this place will be assigned 10. Okay, so but there's a problem now. So what is the problem? The problem is, so now, so when you assign A to this variable, this link is not there anymore. So A is not pointing to this memory. So this memory, fortunately, at this time we are created using stack memory, but if it is also in the heap, this memory we have to manually delete it. So how do you delete an array? So before assigning this one, we have to use delete array A. So when you do that, it will delete this array, and then so first you delete this array, and then only you assign the new memory location to A. So if you do this earlier, you will lose the this connection. Okay, after that you cannot access this memory. So you have to be very careful when you are assigning pointers or reassigning pointers, especially. So you will, when you reassign a pointer value, so what we do here is we reassign. So earlier A is pointing to this one, now A is pointing to temp is this one. So because of that, we will lose some memory, and there is no access to this memory, and this memory will be we don't have access. So this memory will be filled in the your RAM, and your memory will get filled after some time, and we call this kind of situation memory leaks. So you have to be very careful. You may have seen if when some programs you keep running for a long time, and it get very large, and after some time it get crashed. Okay, so this is one of the important stuff when you want to create the memory. So okay, so now we will go to the next step. So up to now we discuss only linear arrays, so maybe one-dimensional arrays, so arrays like that. Okay, so we call this 1D arrays. But in any languages we can have two-dimensional arrays. Why we need two-dimensional arrays? So for example, if you want to have a matrix, so in scientific computing or numerical computing, we use lots of matrix. Okay, uh, I mean almost all the equations can be used or can be developed as a matrix. So we want to solve matrix. To solve matrix, we have to store them. So there are so many examples of using two-dimensional arrays. So how usually matrix look like is something like this. Okay. So matrix is a set of columns and rows. And in a 2D array, we will look the same way. So we can create a 2D array is like here we have 3, 4. Okay, something like this. Okay, so this meaning of this is number of rows and this is number of columns. Okay. So, so when you create, so usually in C, we say we have column, sorry, we have row major format. So you can store a two-dimensional array in different ways. So you can store rows together or you can store columns together. In C we store rows. That means first we store the first row and then we store the second row in the memory and then third row and then here we have 4 rows, sorry 3 rows only. So we have something like this. So we have 3 rows. The 3 rows will be stored like this. So actually in memory it will be 1D array. The compiler handles this. So this kind of statement will be converted to 1D statement and you can access different portions. Okay. So so if you say, so this is 0. So sorry. So we have only 3 rows. 1, 2, 0, 1, 2, 3. Okay. So when you say A 0, 0, this means 0th row and first column. So it is this value. And if you say 1, 0, it is first row, 0th value. So first row is start from here and this is that value. Okay. So likewise, you can access a different location. So we can have say for example, say if we have an array of n and m. Okay. So this means n number of rows and m number of columns. Okay. So we can have an equation for any I, j. Okay. So you can see here, so the size, the length of this one is column length. So that is m. So because we store the first row, in the first row we have m columns. Okay. So we have m columns. Second row we have another m columns. Next row we have another m column. So likewise we will have n rows. So first row, second row, third row, likewise you will have n rows. So this is number of rows and this is number of columns. Okay. So Aij means so this is number of rows. So that means so if it is 0 it will be here. So if it is 1 it will be here. Okay. So if it is second row it will be here. So this one is, you go to the A, address A, and you have to go I number of rows I into each row is having m values, so I plus m, and then you are in the jth column, so j. So this is the this is how you calculate the position. So the compiler will calculate this equation. So if you go to a, and if you go to ith row, means I times m. M is the size of a row. Okay, and then you have to go to the jth column. So for example, if you say a 0 0, so if you substitute to this equation, okay, so a plus 0 plus m, 0 times m plus 0, and it is a, okay, which is correct. And a 0 1 is what? A plus I is 0, 0 times m is 0, plus j is 1. Okay, so this is a plus 1. So which is the second element of the first row. And if you say a 1 0, a plus this is 1 times m plus this is 0. Okay, so you can see it is a plus m. So you go one row, m means you shift one row, and then the next element is 0th element is there. And if you say a 2 3, so you go a plus 2 times m plus 3. So it will be something like this. So you go, so this is a, 1 times a is here, 2 times a is here. So this is the first row, second row. So this is actually third row. So the third row start from here, and then you shift 3 elements. So this is 0 1 2 3. So this is a 2 3. Okay, so this is how uh, the indexes are calculated. So actually in 2D array, when you create a 2D array like this, what is this? So when you create the 2D array like this, you will actually create a one-dimensional array, and then the compiler convert this syntax into the one-dimensional syntax. So you don't want to worry. So how do you iterate through two-dimensional array? So you have, say, integer array a of size 3 and 5. Okay, so you can use, so here you can usually use two loops because you have two indices. So we use I for this one and j for this one. So integer I equals 0. So number of rows start from 0 and less than 3. So until 2 it iterates I plus plus, and then another index j equals 0, j less than, for each column you have 5 elements. So like this, and you can say a I j equals, you can have anything. So I will say something like this. Okay. 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 Sorry. Okay. So this is how arrays are allocated in the stack. So there's another way of allocating arrays. So I will show you. So this is using new keyword. So you can do another way of allocating array. So here actually when you create an array, say integer a 2 3. So this array is allocated in the stack. But we can allocate arrays in the heap as well. So how do you do it? So here we used to have a double pointer, because with a single pointer we cannot create a 2D array. So we used to have a pointer to pointer variable. So when you use pointer to pointer variable, so if you use a pointer variable, you can create say integer pointer variables. Say for example, if I create an integer pointer p, so here you can create something like this. So you can create integers and assign this to p. Okay. Here, what you can do is actually you can create an array of integer pointers and assign it to C. So here what I will do is I will create new integer pointer array, say of 3. So what happens here? Here what happened is, so we create an array. So array size is 3 here. So you can see it is 3. So you create array size 3 and assign it to A. And so the type of the array is integer pointer. So this is also integer pointer, and this is also integer pointer, and this is also integer pointer. Okay. So you have 3 integer pointers. So what we can do is now, okay, we have 3 integer pointers. So what we can do is now we can create arrays with this one, because we can create an array of any size and assign this to this variable, and we can create an array of any size and assign to this place, because all these are pointers, and we can assign array to this one, create an array and store the address here, because you can see now we have 3 integer pointers, and here we can store the addresses of newly created arrays. So how do you do it? So first you create a double pointer. Double pointer means you can store a pointer to pointer. So here you can store addresses of pointer arrays. So we create a pointer arrays. So we have 3 pointers. So for each pointer now, for int I equals 0, I less than 3, I plus plus, for each row, what we have to do is you take ai, so this is a0, a1, a2, okay. So ai equals 0, 1, 2, new integer, say 4. So what happens here now? So I goes from 0, 0, 1, 2. So for each time, so A0 will be a new array of size 4, A1 also having array of size 4, and A2 will be having array of size 4. And here also you can use the same say notation. Okay, so you can access using this double index, and it will, the compiler will create access the array. So A0 mean it will go to this pointer, and from there you go 2 indices down. So if you say A1, 2 or 3, so A1 means this one, and then from here you go for A1, 4. So this syntax will work for this kind of array. So this one is generated using dynamic memory. Okay, allocation. We call it dynamic memory allocation because we can do it using dynamically. That means when the program is running. Okay, so that is all we have to discuss, and then we have to discuss about the dynamic memory allocation as well. So what is this meaning of this one? So so now things have changed. So usually say if you say nx equals 5 and integer a x. So this was not possible earlier. Okay, but new C++, you can, so usually you have to give a constant here. Okay, so now in new C compiler, so I will show you, you can create arrays using variables, but earlier you can only use constant like A5 or something like that. You cannot allocate memory in the stack while the programming is running, but now you can do it. Okay, but usually dynamic memory allocation means we use pointers. Okay, p equals new integer, so you can use x here. So this can be done in any C++ compiler. This can be done only recent C++ standards. So you have C++ 17. I'm not sure whether it is from 11 or something like that. So there are different standards with the year. Okay, 2017 there were standards, and 2011 like that. There are standards. In recent standard, you were allowed to use variables when you are creating arrays. Okay, so I will show you this kind of stuff now. So we will see. So this is what we did yesterday. Okay. Can you see the screen? Can you see the screen now? Hello?
Yes, sir.
Okay. So what we did was here, so we create integer. So I will use p. Okay, so we create double integer pointer, and then we can create P equals new integer pointers, say 3, and then for each value of that array to go through the arrays. For that array, I'm using the variable I, iterative variable I, and I should be less than 3, and I plus plus. Okay, so I will have something like this: int n equals 3 and m equals 5 or something like that. So I will use that n here. Okay, and for each value of that array, so these are 1D array, so one dimensional array, and each place is a pointer, so it's a pointer array of n pointers. So for each location we have to create a new array of integers of size m, and we create for each array like this here. Okay, so this is how we allocate, and then what I will do is I will use to go through these arrays. You have to use two variables. First one is I, and then j less than m. M is the size of column. J is less than m. J plus, and then p I j equals, say, something like, and now I will print. So I have to use the same two loops to print. So I will use cout p I j, and after that, so if after each element I have to print a space, and after each, so this is a column, so you go through the column. After each column I will print a new line character. Okay, so this is what, so we will run this one now. Sorry. Okay, so we will inspect now. That is good. So now you can see, so we have an array of P, and it has a it's a double pointer, and it's stores something like this. So if we okay, continue. So I have to stop sharing this, and share screen and portion of screen. Okay, so now, so you will have something like this. Okay, so you have so you can see I am initializing using two indices ij and I into j. So that means first row will be 0, here also I 0, so j 0, so this one will be 0, and here it has initialized into I into j. So even though you create as pointer array, so you can use this pij, the same syntax to create the array. So in early versions, so you cannot create arrays like this, but now you can see. So I will create another array, say b, using n and m. Okay. So here there's in C++ compiler, Visual Studio, it has this problem. The array is not n should be constant value and m should be constant value. So in different compilers act different. So C++ compiler here is acting different. So I will show you. So today there's no time. I will show you next time. Uh, in some compilers you can do it. Okay. So maybe this. Okay, so this is also not allowed, but in some compilers you are able to do it. Okay, so we will see that in the next lecture. Okay, so now we have covered all the concepts behind arrays. Okay, so you must be now. I will give some example problems, so you can go through them and just start writing and understand the concepts behind pointers, how the allocation, how do you change the size of the arrays, and how do you print 2D arrays, 3D arrays. It's the same in multi-dimensional arrays. And then you must be able to use arrays, because array is the first physical data structure. So array in array, when you create an array, it creates in the memory. But in the other data structures, we use arrays to create other logical data structures like stacks, queues, hash tables, those kind of data structures. We use arrays to implement. We change the implementation, and the physical structure in the memory is similar. Okay. In the next lecture, I will let you know when we can have the next lecture. In the next lecture, we will discuss how to create a linked data structures. So for that, you need to have a very good understanding of pointers. So we are using pointers in the next lecture to linked elements. So we use those links, pointers, to create a linked list. So we use linked data structures in trees, linked list, graphs, those kind of data structures. So nonlinear especially. So we will you will be able to learn them. For that, just read the tutorial, the lecture note I have given. I will upload the video. So there's a problem with me. I cannot upload the videos to our LMS. I don't know the reason. Maybe my upload speed is slow or something like that. So I will upload into a YouTube at present in a private list. It's not public. Only you can access it. You have to have the link. Otherwise, it's not listed publicly. So you can access them in the YouTube links. I will put the links in the LMS. So you can access them, and later sometime I will put them in the LMS as well. Okay. So if you have any questions, you can let me know. So I will start the forum and put some questions there you to discuss. and you should answer them in the forum. Okay, and so we will stop the lectures for today. So I will let you know the next lecture in maybe today or tomorrow, when we can have the extra lecture, because we could not do the lecture last week. Okay. Any questions? Any questions? Any problems? Okay, if you don't have any problems, so we will stop the lecture, and so we will continue from the next lecture. Thank you very much. Okay, so I will stop the meeting now. Okay.